Try it right now. Take your own finger and run it along your palm. Nothing happens. No laughter, no squirm, no reaction at all. Now, imagine someone else doing the exact same motion in the exact same spot. You'd probably flinch, maybe even scream. Same touch, same pressure, same spot. Completely different reaction. Why? The answer isn't about your skin. Your skin can't tell the difference between your own finger and someone else's. The answer is about your brain, and one very specific part of it called the cerebellum. Your cerebellum sits at the base of your brain, and one of its main jobs is predicting the sensory consequences of your own movements. Every time you move your hand, your brain doesn't just send the command and wait to see what happens. It runs a forward model. It calculates in advance exactly what sensation that movement is about to produce. So when you move your finger toward your palm, your cerebellum already knows the touch is coming. It knows the timing, it knows the location, it knows the pressure. And because it already predicted the exact sensation, it cancels out the response before it even registers as ticklish. This isn't a guess. Neuroscientist Sarah Jane Blakemore, working with Daniel Woolpert and Chris Frith at University College London, tested this directly. In their experiments, participants pressed a button that triggered a piece of foam to stroke their palm. When the stroke happened instantly, it barely registered as ticklish. But when the researchers added a delay, up to 2 seconds between the button press and the touch, the sensation suddenly felt far more ticklish. Why? Because the delay broke the prediction. The cerebellum expected the touch immediately. When it arrived late, the brain could no longer cancel it out, and the sensation slipped through as if a stranger had done it. Brain imaging backed this up. 2 regions light up when you process a tickle: the somatosensory cortex, which registers touch, and the anterior cingulate cortex, which processes the pleasurable, almost electric quality of the sensation. Blakemore's team found both regions were significantly less active during self-produced touch than during touch from someone else. Your brain isn't just ignoring your own tickle. It's actively muting it before it happens.
There's a deeper layer here too. Tickling isn't actually one sensation. Scientists split it into 2 categories. The first is Knismesis, that light, crawling feeling from something like a feather or a thread brushing your skin. The second is gargalesis, the heavier, repeated pressure that causes real laughter and involuntary squirming. The kind you feel under someone's fingers digging into your ribs. Only gargalesis produces that uncontrollable laugh response, and it's this type that completely disappears the moment you try to do it to yourself. So why would evolution build a brain that cancels out its own tickle sensations at all? One leading idea is that ticklishness evolved as a built-in vulnerability alarm. The most ticklish spots on your body, your ribs, your neck, your underarms, are also the exact areas most exposed during a physical attack. A sensation that forces immediate laughter, flinching, and protective movement is a fast way to defend those spots the instant something unexpected touches them. But that system is only useful if it reacts to the unexpected. If your brain screamed threat every time you touched your own side while getting dressed, the alarm would be useless. So your brain learned to silence the alarm for anything it already predicted and keep it fully armed for anything it didn't.
This is also why tickling has always been social. It rarely happens in isolation. It happens between people who trust each other, parents and children, close friends, partners. The laughter it produces isn't just about the touch. It's a shared signal of closeness, built on a system originally designed to detect danger. There's even a clinical side to this story. Some researchers believe that when this predictive canceling system misfires, when the brain fails to correctly separate self-generated sensations from external ones, it may be connected to certain symptoms seen in conditions like schizophrenia, where patients sometimes struggle to recognize their own actions as their own. So the next time you try and fail to tickle yourself, remember what's actually happening. Your brain isn't broken. It's doing exactly what it evolved to do, running silent predictions thousands of times a day, filtering out the expected so it can stay alert for the one touch that shouldn't be there. Thank you so much for watching. If you enjoyed learning something new about your own brain today, hit like, share this with someone who needs to see it, and subscribe to the channel for more science explained simply. See you in the next one.